Hello grade 12s, welcome to this lesson where we'll be looking at the application of the fundamental counting principle, permutations, the use of the factorial notation, and the placement diagram. And we have two questions to help us just to unpack those different subtopics in probability. And here's the first question. Okay, so we are given a 6-letter word called stated. And with this 6 letters, we want to generate as many words as possible and also account for repetition where there's a need to. And in this case, definitely, there is repetition. You can see that the letter T is being repeated, and we will need to account for that repetition to take care of ambiguity. Okay. The first question is asking us if our words had to start with the letter T, how many words in total will we be able to form? Okay, so let us look at the board. And of course, we going to make use of a placement diagram. How many places? 6. Okay, this word must start with T. Okay, so this is fixed. We only have one choice to make. Only one letter to choose from, T. Okay, in the second choice, or in the second place, you have 5 choices, okay? Because if you took away that T which you placed there, it doesn't matter. That T or that T, it is the same T, okay? That's why I'm saying we need to account for repetition, as we proceed with the questions. Okay, how many letters are left? 5 letters are left to choose from, okay? If we now are at the second position there, we pick one letter. Let's say we take an E now. How many letters are left? 4. Okay. Let's say we took away that guy, the S. Okay. And then here, how many letters are left? 3. And clearly you can see it's 2, 1. Okay. That is gone. That is gone. Okay. The fundamental counting principle says if you want the total number of words that you can form with this type of setup, you take the product, okay? So you multiply everything, and as you can see, it's 1 times 5 factorial, giving you what? 120 words that can form from this, okay? Now, the second question is asking how many words in total can you form? There is no restriction there. In the first question, we had this restriction where the word must start with T. The second question, it's all the different words that can be formed by this 6 letters. However, we know that T is being repeated. So we will have 6 factorial over 2 factorial. Okay? Giving us what? 360 words that we can possibly form with this combination. Remember, this 2 factorial is to take care of the repetition of T. Okay, good stuff. And the last question, question 3, is asking what is the probability that in this 360 words, suppose they were in a bag, okay? Let's just use our imagination, and we had to pick randomly, okay? What is the probability that we'll pick a letter, or rather a word, that starts with the letter T, right? So there are 120 words out of this 360 words that start with T. So therefore, the probability will just be 120 over 360, giving you 1 over 3. Okay, so that takes care of this first question. And perhaps you may be asking, what is going on there in terms of the placement diagram. Okay, placement diagram still has 6 places. Okay, there's no restriction. So unlike this one, in the first place here, you're going to have 6 letters to choose from, okay? And then in the second place, you're going to have 5 letters to choose from, then 4, 3, 2, 1. The principle says you take the product, and this represents 6 factorial, okay? However, you have to account for the repetition of t by dividing by 2 factorial, okay? So I hope that clears the air, and it helps you to obviously understand this calculation better. All right, let us move on to the second question. Good. Since we've read the question, Jewel is choosing a book randomly from either shelf A or shelf B, and also choosing randomly a fiction or a non-fiction book from either shelf A or shelf B. So question 1 is asking, what is the probability of Jewel choosing a fiction book? There is no restriction here on the shelf. So what do we look at? Tree diagram is very important in this type of questions, and is very critical for you to prepare it effectively and correctly. Okay, obviously there's a 50% chance for either shelf A or shelf B, okay? And then depending on the number of books that are fiction and non-fiction, then you prepare your fractions or your probabilities there for each shelf. And I believe this is clear to you in terms of how the tree diagram for this scenario looks like. Okay, so what are we going to look at? We're going to look at the probability of choosing fiction from shelf A plus the probability of choosing fiction from shelf B. Okay, so let's go to shelf A. We are there, okay, and then that is our branch. Okay, so we have 1 over 2 times 10 over 16 plus shelf B, okay, and where we go in fiction. So that is our branch, okay. So it's 1 over 2 times 8 over 20, okay, and this gives you 41 over 80. All right, so that takes care of the first question, right? So the second question is asking, what is the probability of not choosing a fiction book from shelf A? In other words, we need to exclude that from our calculations. In other words, where are we? Shelf A, and we don't want this guy, a non-fiction book, right? So there we are. So what are we going to do? This is equal to 1 minus probability of non-fiction in shelf A. And this is equal to 1 minus 1 over 2 times 6 over 16. And this gives you 13 over 60. Okay, so that takes care of this question when it comes to tree diagrams and knowing how to use them effectively to answer questions. So grade 12s, this will take care then of this lesson. I believe that it was helpful, and you go on with practicing as many problems as you can under probability so that you can succeed in the examinations that obviously are ahead of you, but you definitely want to excel in and you want to nail those exams. All right, so thank you very much for tuning in and being a subscriber of this channel. Keep sharing the word, keep spreading the word so that more people can benefit. All right, go out there now and be excellent. Sharp, sharp.